I think this guy. Saying like they were complex roots.
They might have been complex numbers. Yeah.
They were imaginary.
Like a mix of. What?
Which one is the root?
Yes, the root is the 0. 0 is the root.
Okay, so like from now on, when you tell us to find the zeros, we have to find if there are no zeros, we have to find it out of it.
There are always zeros. Sometimes they're imaginary.
Okay.
Yeah? Okay, so not talking about quadratics today, though. So if we talk about a cone. Is there an extra? Oh, there's an extra, so I'm printing one for me. Go figure, I want to print one for me. So if we think about a cone and how it's made, the issue that people run into is thinking about two different circles, which is really happening. There's the circle at the bottom, the base circle, which is easy to deal with, it's pi r squared. But then this lateral area, and we call it the lateral area because it faces outward, it's like lateral, like a lateral pass is a sideways pass, which I didn't know until a couple years ago. Dude, I played marching band. Like, I didn't play football, I played marching band. So I knew the rules. I knew the rules of marching band. I didn't know the rules of football. I knew when to cheer at football and when to play. Like, you know, oh, they scored. Dun, dun, dun. And I did not play trombone. All right, so this is what messes with people, and I actually don't like how my shapes kit makes this look almost like a half circle, because really, it's always going to be some portion of the circle, but it might be a small wedge, and it might be a much larger wedge, depending on how tall your cone is and how fat your cone is, right? How big the bottom circle is. If I keep this lateral length, like this edge, the same, but widen out my base, this is going to like get much shorter, right? Now, if I let the lateral stretch and I just widen out the base, my lateral length would get longer, and then this is going to have more area, of course. So the formula for this, though, is pretty straightforward. Pi r s plus pi r squared, where s is the slant height. Now, the dangerous thing about this is when we deal with the volume, we're using the actual height. When we're finding the area, we're using the slant height. So I have a variety of problems here that we want to review and make sure that we can get right. So the first couple are pretty similar to each other, and we should be able to recognize the difference in the two cones. It took me a little while to find two images that were that closely related. But then the third one here, we got to do a little bit more manipulation. But now we're reviewing surface area, but if we also want to find volume, that would be a good practice review as well, which then is going to incorporate some Pythagorean theorem. Wait, what do we need Pythagorean theorem to find surface area anyways? Because we need to find the height of the length of the slant. Well, not for the first two, because the first two tell you the slant height. Yeah. Yeah. Beyond lack of calculus. So that's it. That's it. Yeah. Seriously, calculators. 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 Get them while they're hot. You're welcome. Now, be comfortable. Hey, please. Be comfortable finding these values both in terms of pi and then decimal, Stephen. So if we find it in terms of pi, then also do the multiplication to find the decimal. For the first one, I got 282.7. Find that. 0.7. Yeah, now, actually, the first one there, can somebody find the height for me? 12. That's another famous Pythagorean triple. Well, yeah. That's another famous 5, 12, 13. It's a famous Pythagorean triple. When you see the 5 and the 13, hopefully, well, it doesn't really matter if it activates your brain, but it can if you start to memorize them. Hey, getting old sucks. Your skin dries out. Hence, I saw a couple of you like, what is he doing over there? Yeah, my knuckles are really dry.
Oh yeah.
And my dog has been shedding like ridiculous. I'm dry. My dog's shedding everywhere. The backyard's still muddy. The world is just
homework.
I mean, it depends on how comfortable we all get.
Oh, this is oh.
It's not like
Parrot.
guys. Remember, what we practice is just to make sure that we know what we need to know. We're getting to the point where we've learned like almost everything. 0.16666.
I was doing stuff squared, but I forgot to get out of the square. So that's 18. 2 plus 21 squared.
Oh.
What do you get for the slant height of the third one?
That
Yeah,
would
third
be
one.
called
What do you get? I got 27.
22. I feel like that is
Yeah, I got
incorrect.
22.8 too.
Wait,
Yeah, that's
square.
what I have.
18 squared was 21 squared.
No, wrong. 18.
Hold it.
Ooh, trap door. There's a trap door.
It wasn't it.
Satya falls, so we don't know.
Did I tell you guys about the mom that called me?
No.
There was a mom of a 7th grader who called me. Kind of upset, but upset's probably not the right word. She was like heated about that they had found 3 different answers to the same math problem. Her son had one, she had one, and her high school daughter had it. Like, they all had different answers. And what I ended up having to tell that mom was that she and her daughter had fell in the trap door. And that was an interesting conversation. She wasn't like upset about it. She was like,
Wait,
ah.
why did you have the chance to do that?
She called me. This mom called me saying, I just want to know who's right. And it was very funny. So this is 12, famous Pythagorean. Did we solve the height here?
Do we want to?
I mean, if you want to find the volume, if you want good practice, find volume and surface area for both 10.
Volume.
Wait, how do you find volume?
It's like 1/3. You find the circle times the height.
Well, we can do 15 squared minus 5 squared and do the square root of that, right?
So you find the area of the bottom circle and you multiply it by the height and divide by.
15 squared is 225, right? 5 squared is 25, so I think we get radical 200.
So to find the area, you take the circle area at the bottom, multiply it by times the height, and multiply it by 1/3.
It's weird using this after using the pink ones normally.
Wrong color. What?
Area?
Yeah, in my brain it just looks wrong. It's
Like the
14.
bottom circle. So you take
Check your work.
area.
Guys, I think this comes out to be 14.14.
Just write r squared pi.
It's pi r squared.
Pi squared
Yes,
multiplied
r
by
squared
height
pi is the
divided by
same
3.
thing.
Times height divided by 3.
But it
Yeah.
sounds worse, Steven.
Yeah, r pi squared sounds weird.
R squared pi.
That wouldn't work. Wait, it would. Never mind.
And what's the volume?
R pi squared would be wrong.
Yeah, no. R would be.
Pi squared
Just
r.
squaring pi instead of.
Pi
It
to
doesn't-
squared would
it
be
doesn't matter.
right.
What did we get for the slant height out here?
22.8.
I got it.
22.8.
Wait,
Yeah.
what?
8.5.
It's got to be bigger
Oh,
than
I got
21, that's for
three.
sure.
Yeah, 22.85.
Square root of
22.847.
All right.
Actually.
Let's check our answers here.
8.
If we do surface area of this cone, entire surface area, including the base,
282.7.
282.7
Oh, yeah. Got it right.
4.
Or 90 pi.
or 90 pi.
314.1.
For volume.
Oh, no.
What? It would be 1/6. Volume, I did.
You got what?
I got 314.16.
That's just
Wait, what? You got
I got
314? I was talking about surface area
I
for the
think
next
I
one.
jacked it up.
It's just
Although
100.
that's I just stuffed it up. Wait, what's the equation for volume?
So now we need to check this, but it's a third of what the cylinder volume would be. So do the cylinder volume 25 pi times 12.
Yeah, it's 314.
Okay, so 25 pi 12. I can just type all that in as a string.
Yep.
942.
This is pi r.
Divide that by 3, and we get 314.1. Wait a minute, 314159265.
Interesting. Ancient.
It's 100 pi.
It's 100 times pi.
Wait, hold up. So,
Dude, it's pi r squared.
so the formula for volume is pi r squared times height
Pi r
divided
squared.
by 1/3.
Stop yourself.
Hold up, wait a minute.
1/3 of what the prism shape
Yeah.
would be.
Yeah.
So here, that would be pi r squared times h. But don't try to memorize things. Just
Think of it
realize.
like-
Go ahead.
I was saying like our I don't know. Chris is the only Chris and I think is the only person that knows Miss Schreiber. So she
Oh,
was
I know
like
Miss
eighth
Schreiber. Hey,
grade- She
Casey.
was like the 8th grade
She's a math counts
so
coach.
she did like a demonstration. It was like to teach us like the volume of cones. So she took like a cylinder and filled it with water.
We can
Oh,
do
yeah,
that.
yeah,
I
yeah,
just don't
yeah,
normally do
yeah,
that
yeah,
with you
And
guys.
then it was 1/3. So that's how I remembered that it was multiplied by 1/3. It's like finding the cylinder which you find the base and the height and then
Oh,
Yeah.
I remember doing this.
So, this maybe won't make as much sense to like understanding that, but this holds true no matter where that vertex point has been pulled. So if you can envision a square base prism and you pull up from the base out to one of the top corners, that expanse that comes down to the bottom takes up 1/3 of the volume. So we could do that again, but like flipped upside down.
And then again.
And then again, and the third one would be like really awkward to fit the rest in. But imagine 2 of those won't take up the whole prism,
Yeah.
right? Because it would go like up, and it would be on one face and one
Yeah,
face.
but this side would still be empty.
Yeah, so it'd still be open in one chunk of it, so you know it's got to be less than a half of it. So just kind of like be able to play with it in your brain. Let yourself imagine some things. Our second one here, slightly taller version with the same base. So we can actually share some values here if we want. But our surface area came out to be how many pi?
14.1.
100 pi?
2.1592653.
Hold on. Wait, what?
It's 100 pi. It's 14.
314.2.
2654.
1/6.
No, it's 1.15.
Notice what I did here. Be careful. These numbers are nowhere close to the same because they're different units. Right, now we got the same numerical value. Oh, yeah, because you rounded at the 10th place, or you used a different version of pi. It all comes down to pi rounding. Okay, whether I use 3.14 or pi button or 3.1415, whatever. If we do the volume here, 1/3 of 25 pi times the height of 14.14.
What's the volume? 324. I got 324.63124009. 370.24.
That sounds too big.
We got some reason I got
I got
7.18.
I got
Alright, well, I'm going to calculate
I
this.
got 2 4.
For some reason.
I got 900. Lauren's wrong.
I got 900.46.
Lauren's wrong.
That was my first.
Lauren's wrong.
Look at your last number you typed in.
I got 370.
That's what I did.
Oh, for volume? Oh.
It's 14.14.
I got 370.
I get 370.18, so anywhere close to that. Oh, Chris, congratulations. Not on your mouth string instrument, but on a plant sale.
Wait, can you make
So
Wait,
good.
did he-
Wait, you weren't here? Oh, Chris, you won 3rd place in the plant sale.
Yeah, I know this.
Congrats. You get a gift card. Good work.
Congrats, you are.
Thank you. And we come.
Yeah.
You get
So if I scream at him, will
Nine
Big oxygen.
for your one leg.
We want our oxygen.
21 for your other, unless I did this wrong. So 9 squared is my one leg. 21 is my other leg. So that gets me 522. Square root of 522, 22.84. So really this could be 22.85 because it rounds up. Try to do that.
No, it's fine.
What do we get for surface area in terms of pi?
286.2 pi.
Wait, spheres is that easy?
Why are you on the back?
It's 6'3".
Did we flip to the back yet?
Yes.
Are you helping me with the front? No. Alright, what's this come in decimal?
899.1.
I got
900.
900.
I got 900.
If you do not change, if you
the exact thing. It's actually
Okay, so you are off
and that 100.4
by less than 1. It's okay.
I was right.
Now, this does iterate. Hey, I need your attention. This does reinforce. Please pay close attention to what they ask you to use for pi. Normally, they'll use 3.14 because they're not sure that every calculator will have a pi button. And I'm not sure if the test calculator has a pi button. It's the one on the program. And we, like 8th grade, you guys get calculators both days. And for the test that you're taking, you get a graphing calculator. So, at least, unless something changed, when you're taking a high school test get graphing calculators. Volume.
1,781.28.
Yep.
Sorry, what? How many thousand?
1,781.28.
So, difference between units squared, units cubed, we'll assume meters.
Units cone.
Units coned.
No, it's millimeters.
And spheres. So, what is our volume formula?
I'm not sure.
1/3.
No,
it's 4/3.
4/3. Right? Oh, wait, sorry, one more cone. Be careful.
Why would you
How,
do that?
if this cone doesn't overlap, how much cone is there? Because now you can't just use the formula. You have to think, which part of it do I need?
What do you mean?
So we're not counting like the base then for this.
I'm asking you, how much cone is there?
That is precisely what he said. Are we not counting the inside?
What do you mean the inside? How much cone is there?
You never know.
No, like actually, you can't.
What if you want a lid on your ice
And
cream?
it goes all the way around. There's a
Why?
wide piece of triangle missing. I feel like I'm like
Yes,
actually
I get it.
I see it. Actually,
I see it.
It doesn't tell you.
Steven, you were extra.
roasted.
Feel like Chris, there's a triangle.
Oh, wait, also that podcast thing.
Yes, but when we get done with this.
Yeah, about to say, before I forget, I'm saying it so the responsibility's going.
Wait, how did you guys do on the math count thing?
Oh, here.
What thing are you talking about? The video challenge we submitted too late. Yeah, I now come to realize we probably need to split math counts through the fall and winter of, do you want to do the competition or do you want to do the video challenge?
The video was really bad.
I wasn't going to say that.
Well,
It
made
was,
some
but-
poor executive decisions. What was your video?
1 squared plus 6 cubed.
Did we just do?
I mean, it wasn't completely terrible.
37.
Like,
37.
The fact that we did all the editing, recording, and everything on a phone, like, it's fine. You know,
Oh darn.
just fine. It's not good, but fine.
Which is better, pi squared or squared pi?
Wouldn't the
There's
inside
no pi r squared because the pi r squared is the base.
Wouldn't the inside always count as
Thomas,
square?
no.
Wait, are you gonna shut down his idea?
Thomas, no.
The inside square.
No. You. We do not say that here.
Are you sure about that?
Oh, 6.08.
1 pi.
I got
So-
19.5.
We get like 6 pi essentially, so 19.
1.15845.
What do you mean
Now-
five? There are 2 zeros.
Of course, hey, rounding, quit arguing rounding. Of course,
You did it wrong.
there would be some overlap. What? 1 0. Okay, I don't care. Whatever. 1. Fine.
1. You run for
Oh,
I really like to
sorry,
hold
I
on
didn't
to
run.
things. So this just 1 because I found a picture of my ice cream cone. I like ice cream.
What about
And
the
2,
inside?
when on the test, this is why memorize this formula is dangerous. I forget what formulas are on your formula sheet, and you can look it up. But be careful. A lot of these problems are written to make you think and not just apply a formula. But if it's talking about like a tent, or so like analyze what they're actually asking you, and is there a base? Is there just sides? Is there like an opening somewhere? So if they talk about literally a traffic cone, I've seen this problem. How much plastic is there? the top's cut off, right? It has a hole in the top. You'd have to remove that much area if you're just talking about the plastic.
How do you
So-
do that?
You find the area of that cone and take it away from the whole cone.
And then there's what about the inside of
Well,
your
there is a, and
What do
how do
you
you
mean,
do
what
that
about
whole
the
thing where like,
the inside of surface area too.
Okay, we're talking about if. So I guess this probably makes more sense in my head because I had this whole talk with my one class yesterday. Buddy and Duff, two professional bakers, if you know who they are currently like having a bake-off competition on Food Network. Each week they do a new episode. Like a week or two ago, Buddy made, or Duff. Yeah,
how do you make stuff?
Duff made waffle cones. And when you make a waffle cone, it's literally you make a waffle and you undercook it a tiny bit and then you curl it. So what we're talking about is when laid flat, what's the surface area? Now, be careful because when you say inside, when we talk about area, we're not in 3 dimensions. Right? When we talk about area, we're just talking about flat object.
Yeah.
So we would need over 19 inches squared of cone to make that cone because, right, it overlaps. But if there was no overlap, it'd be 19.1. Now we got to move on to spheres.
Although Stephen did put up a good point. There's a little indent in the cone.
Yes, that little cutout at the top. Now that's just from the roundedness of the other cone and you not wanting to break it. When we talk about volume, guys, these formulas actually should make sense in your head. We have 4/3 volume.
Yeah, so
Volume is 4/3 pi r cubed. We have a 3 in the denominator and a 3 in the power.
I could just multiply that.
For area of a sphere, surface area of a sphere, instead of having the 4 divided by 3, having a 3 in the power, get rid of those 3's, knock your power down by 1, and just get rid of your denominator, and we have 4 pi r squared. That's it.
Wait,
That
so
seems
here's
too-
four-
Why is it cubed up there?
Because this is volume. We're trying to compare the two different formulas. Volume uses a 3 in 2 places. Surface area only uses even numbers.
Oh, there is no.
What?
So is the
Pi
area
not
just
count.
length times width to the power of 1?
Length times, what are you talking about? Length?
Probably a
What?
rectangle.
Sure. But if it's a square, it's the edge length squared. What are you talking about? Power of what to the power of 1? Number or units?
Never mind.
I think you're asking a question that doesn't make total sense.
How big is the power of 1 is it? Always.
I mean, Satya, you're to the power of 1.
Ignore
So are
that.
you.
Stop this madness.
That's a TV commercial.
Is it?
Something about like bankruptcy or lawsuits or something. They're like, stop the madness now.
March Madness.
So, guys, this seems too easy, but that's it. It's 4 pi radius squared.
So this is it.
So if you make
Why does it even work?
the circle in the middle, that has an area of 25 pi, right? And how much we would need to cover the whole sphere? 4 of that. Done.
Why though?
So we can get deep down into this. I bet it would take more than 15 minutes. We can get there. All I'm trying to make sure is you're comfortable for the test. The test isn't going to ask you, write a proof of why this works. We still have a month of school left to dig into. Let's look at why this works. Now, to do surface area of a sphere, that pi r L, that's not that hard to derive, especially with the picture that I gave you beside the other one up on the front of your paper. We can derive that fairly easily. This is a tad bit more complicated. The derivation of, and that's how you say it, guys. If you're looking these things up, it's called the derivation, like derivation, derivation of whatever. So this would be derivation of surface area of sphere. Yeah.
You said here, why did they multiply by m squared?
That's your units. That's meters squared. I know it looks weird because it's typed, right? So this would really be 314, which ironically, same as our cone on the front.
Whoa.
Right? So we could actually compare a cone with the same surface area as this sphere was this one, right?
And it has the same radius.
So a cone that's 5 by 15. Actually has the same surface area as a sphere with a radius 5. Interesting. Everything matters. Except like color. Color doesn't, like a purple sphere versus a red sphere, like that doesn't matter in math.
Well, of course it matters.
That's that
It affects how much light is bouncing off of it.
Well, yeah, but we're not in math.
And the different types of
Alright, so practice this.
Yeah, what is that though? Ready game.
Find volume and surface area for all of these.
Okay, Nick, heck up.
You're gonna see me take my teeth out of my mouth later today.
Chris, I'm like.
Oh, is that like a? Is it like a kind of like a what do you call it?
Retainer?
Retainer. Like
No, it's like a retainer. So you know, like your braces, you have rubber band you put on. After you put your retainer on, like for a few months, you get the rubber band on.
he has rubber bands on.
Yeah. So this is like a closer kind of state.
No, I'm not. I just got these today.
No, like so before they put the thing retainer, right?
There was no.
The retainer is
He's got
supposed to
those-
This is
retain
just the only thing. This is the
Yeah,
only
I
thing.
have
the
In case we put 1 in pi,
I
1
retainer on
in
it.
decimal.
The retainer is for the end. It's supposed to retain
Oh,
the
guys,
shape
this should
you
go
already
in the
have from getting
That's what I'm
braces.
wearing.
I wear two. I wear one too.
If we want to do terms of pi and decimal form,
I don't do
That's too many values.
you're weak.
Yes.
All of you with the mindset of like, man, you're sitting here wasting your time talking about why Chris has rubber bands in his mouth.
That's
Use
not-
your brain.
Not all of us though. That's not
We
what
did.
talking about his rubber bands.
Is it making you better as a person?
Yes.
Is it having you grow? Is it challenging your mental abilities? Is
Yeah,
it,
it was cute.
Slightly.
if we want to have this debate, we can have this debate.
We're
So,
sitting here and-
4/3 pi r cubed. Well,
24 pounds.
yeah, that's 81, so it's going to be 81 times 4. Well, 81 divided by 3 actually
Wait, but I
nicely.
thought
So
it
it's,
was 9 cubed.
324 pounds. That's right.
what?
Volume.
Yeah,
Surface
9
area.
cubed.
Oh, you're doing.
I did volumes first because we
Oh,
knew
oh,
these formulas already.
Yeah.
It's just what I have written here.
9 cubed is not 80.
81
Or, yeah, sorry, it's 81 times 9. So give me terms of pi.
324.
9 times 4 is 35.
That's surface area.
Okay. Oh, that is?
That's surface area.
Guys.
Whoa! I just whoa.
Is that still surface area?
1017.
Volume, I have the actual number.
Volume, I got the actual number too.
Alright, what's the actual number, Thomas?
3053, but my decimal places might not be the same because I originally
Yeah.
did it
0.6.
squared and then I
Okay,
just multiplied
0.6,
it by
something
the
like that.
I got. But then I don't know what the
This is probably like 1,000 pi something. Your test is probably going to ask you to put it in. Actually, I can't really say that. I don't know if your test will want you to
I'll
put
do
it
the
in pi
last
form
one.
or in decimal form.
A lot of people
I already did all of it.
They did it like
Yeah, because they didn't leave the classroom when we dove into this.
Yep.
Volume and anyone have pi terms on this, or do we just have decimal terms?
No, I got
Okay,
that.
good.
For volume, I don't have.
Chris,
volume.
what's pi terms for
My
my
term
middle?
for volume 1,960 or 36. Or no,
1,936.
that's the surface area. Sorry.
Yep.
The volume is 14,167.3 repeating pi.
Oh, did you guys do that?
Because
The three is
this is big.
Repeating 3. For the.
Yeah.
Is the surface area pi?
Yes, this was that, and then
6082.1.
6,082.
Yes. I got 0.
Yeah, 6082.
And then
Wait,
44,600.
That's from volume. Like the number.
44,000.
Oh,
602.
point
144.
Whatever, I'm rounding. Y'all can get over it.
No.
But you don't think they're right? Why do you not think they're right?
Oh, I got it.
So, what's your radius here?
4.
4. We got to deal with that first. Be careful.
64.
For volume.
Yeah. I mean, no, surface area.
Wait, wouldn't that be 128 by then? I got 128 now.
For surface area or volume.
Surface area. I got 128.
Did you use 4 or did you use 8?
I thought I used 4.
So for surface area, it'd be r squared, right? 4 pi r squared. 16
I didn't use 8, but I don't know what I did.
surface area in the decimal.
I didn't use 8, but I don't know what I did.
So what?
Surface area, I got that.
No, never mind.
Six more teeth until you're
And then for volume, I got 268. Yes.
So, this was by request, right? We talked yesterday about what was still iffy in cones and spheres. Seemed like we were still a little nervous. Are we more comfortable
Yes.
now than yesterday?
Yes.
So now, same question again. If we relook at everything potential for the test, everything we've done this year, and or anything from previous years, is there anything else you would like me to prep? Because I just like made this worksheet for us, right? I can prep anything we want that you guys feel like we need to review before the test next week. So if we go back to what...
Different, like, formulas for everything.
No, you get a formula sheet. Yours is actually pretty decent. The high school formula sheets or reference sheets are pretty decent.
Can
What?
I go write up 2 things on there?
Sure, but does it relate to a problem in the book?
Yes.
Then do you just want me to pull up that problem?
I do not know the problem because there's a bunch of like stuff like it. I just need to know how to do it.
Green doesn't work, Satya. How many times do we have to say this?
How many times do you have to teach you this?
There's lesson one.
Actually, can we all promise each other we won't tell Satya next time he picks up green?
Yeah.
Yes.
Okay, well, x squared plus 6x plus.
Is this 11? Is 11?
I was gonna write 11, but now I don't want to.
It's 11. This is the same problem we had
3
minutes ago.
x minus 4. How do you solve that?
Well, make it 12 and 11, and we can tell
Set them equal to each other.
Yeah, I know. Like, so I do x squared plus 6x plus 12 equals 3x minus 4. Anyone know how to solve that?
I don't know
more
one
difficult.
side.
First off, stop making your fours like that. I've told you this for months.
Well, first off, if you want to do is look like it's that.
You subtract 3x.
There you go.
You're bad.
That,
You did it a different way both times.
Everyone else can write it.
So, here, wait.
I'll show you. I'll show you. There's a
No, wait.
Thomas calls dibs.
Dang it.
Thomas, if you make your fours like that, you're sitting there.
You're fired.
You are.
So I'm just gonna get fired.
Well,
And then you can do x.
We just put it in the.
So it's 1.5 squared.
2.25. That would be it.
yeah, that's
That
not
ain't it. That ain't
I
it.
tried doing that and that doesn't work.
Oh, you could force this way. Hey, there are multiple ways. Quit yelling at a peer, telling them they're wrong. There are multiple ways. Well, yeah, but you got to remember. Actually, the quadratic, I believe, is on your reference sheet. Have you guys done your math practice yet?
Yeah, it was only.
Did you click high school?
Yeah.
10th grade.
It was.
So we're going to get a complex number, Satya. This is where it gets funky. We have to square root a negative, which is quote-unquote impossible. So our answer, here, hold up, I got more screen for you. Our answer ends up x equals the positive or negative square root of negative 15.75 because it's a gross imaginary number.
So basically, what we gotta do is we gotta get all.
Minus
13, no. Yeah, 13.75.
So we get all of this on this side.
Yes. 1.5
Oh,
squared.
why did I get that? 1.5. How did I get 5?
So
Yeah,
like,
it's not
1.75 is not 0.25.
you want to have
1.5 squared is not
x squared plus, like, let's say now 5x.
Can I show the in-between real quick?
Satya, your handwriting's bad.
What are these numbers?
So, hold up. Give me a second. The in-between right here, to make sure we're all still comfortable and where we got a goofy number, is right here. What we actually do is x squared
It's not 15.
plus 3x equals negative 16. Then we look at if I make this side perfect square, it's x plus 1.5 squared. That gets that and that, but also a 2.25. So this needs to come up 2.25 and ends up at negative 13.75.
What do you
Yeah,
do?
I
So
did that
this should be 13.75.
Yeah.
What do you do with the complete square?
So from there, like from this step?
Yeah.
Okay, so here we then are applying a square root on both sides to get rid of this square.
And then you, okay, I'm good.
Then we have x plus 1.5 equals radical, this number we don't like, because it's imaginary. And then,
So are there actual answers to this stuff?
yeah, they're imaginary. But the imaginary aren't imaginary, they exist, they're just in the imaginary set of, in a 3D graph. Yeah, you would find an intersection in a 3-dimensional graph using imaginary numbers.
These two equations don't intersect.
They won't probably in our Euclidean geometry. In Euclidean geometry that we're normally stuck in, that we use real numbers and we don't use you won't see an intersection, but there is an intersection, right? Because so remember that image from our lesson on imaginary numbers are real, where the graph comes out off the paper. So that's why we won't see it in our, like, what we look at the graph, but if we could come up out of the paper, then we would. Yes.
Just to make sure, radical -4 is 4.
2i. You take the square root of the number and the square root of -1. So the reason I happens to review I. Maybe tomorrow we should just do like random review questions.
Sure.
We factor, guys, we factor this, and then this becomes 2 radical square root of negative, or radical square root. And the square root of -1 we know is I. That's why I have to. You can show all the work.
We should have students ask questions.
I'm still kind of confused about
Domain are all input x values that will work in the situation. Range are all the resulting outputs when given that input.
Domain is x, range is y.
So if I'm talking like growth of my tomato plants, I'm going to have a set number of days that are my input domain, and my range will be the output heights. So my range can't be negative, because my height's not going to go negative into like the upside down. And my tomatoes are growing for the weird animals down there. And my domain can't be negative, because I can't go back in time. Right? So that's like where, given certain situations, realistic.
You can't go back in time.
What, you can? Okay, here's your homework. Bring to class tomorrow something you don't have confidence with.
Chess.
Now, if you don't have anything you don't have confidence with, whatever. But if there's anything for us to review, we want to do that. Okay? Bring me my have it be like purpose.
Watson, I have my.
So I'll see what I can do. I'll talk to Mr. Green. So now he uses Kahoot more often.
Drags Lauren to class.
Brings parents in.
Whoa, hold up. We cannot leave yet. We're way too early. Cafeteria won't be ready.
How do you do it?